All right, let's get right into it. We're talking about a seriously cool new technology that is completely changing how we see and respond to one of nature's most powerful forces. We're going from fuzzy, often useless pictures to maps that are crystal clear and, crucially, available right in the middle of a disaster. And it's all thanks to a new eye in the sky powered by some very clever AI. You know, this is the fundamental question for any disaster response team anywhere in the world. When a flood is happening, knowing what's going on the ground is everything. But the very thing causing the disaster, the storm, the clouds, the rain, the dead of night, that's what's blocking our view. For a long time, the answer to this question was, well, with a whole lot of difficulty. So traditionally, we've had two tools, and frankly, both have a huge flaw. On one hand, you've got optical satellites. They take gorgeous, high-res photos, just like the one on your phone, but only if it's a nice, clear day. The second a storm rolls in, they're completely blind. Then you have radar satellites. Now, these are amazing because they can see right through clouds day or night. The catch? The images they send back are messy. They're noisy, they're grainy, and they are incredibly hard to interpret accurately. It's a classic case of having two bad options. So, that brings us to our first major topic, the race against the flood. In those first critical hours after a disaster, every single second counts. But the tools we've been relying on have always had this massive blind spot, right when we need to see the most. And this isn't just some abstract technical puzzle we're trying to solve. This has massive real-world consequences. A report from the University of Waterloo, which the researchers cite, estimates that almost 5 million Canadians live in coastal areas that are becoming more and more vulnerable to flooding. This is a huge, growing problem, and not just in Canada, which makes finding a solution more urgent than ever. So the dream, right? The holy grail for disaster mappers has always been this: somehow combining the best of both worlds. Getting a picture-perfect, easy-to-read map of the ground, but one that you can get in the middle of a hurricane. For years, that's felt like science fiction, but a breakthrough has finally come, and it's from the world of artificial intelligence. And that leads us right here. A new contender has entered the ring, a powerful AI model built to solve this exact problem. It's called Fapnet, and it is a completely new eye-in-the-sky. Fapnet, which stands for Fusion Adaptive Patch Network, was developed by researchers at the University of Alberta and a company called 3VGImatics. And what you need to know is that this isn't just some generic AI they repurposed. It was designed from the ground up, purpose-built to tackle the specific challenges of noisy radar images and produce clean, accurate flood maps. So, what is Fapnet's secret sauce? What makes it so much better than what came before? Well, it really comes down to two key innovations. Two, let's call them superpowers, that let it see what other models just can't. The first superpower is its Data Fusion Module, or DFM. That's all about how it sees the world. And the second is the Neural Adaptive Patch Algorithm, or NAP, which is all about how it learns from the world. Let's dig into both of those, because this is where it gets really clever. Okay, so that first superpower, the DFM, is just brilliant. Instead of trying to make sense of one noisy radar signal, it fuses together multiple streams of data. It takes two different radar polarizations. You can think of those as signals that bounce off of things in slightly different ways. And it combines them with a critical third piece of info, a 3D map of the ground's elevation. This is the perfect way to think about it. Giving the AI that elevation data is like giving it a pair of 3D glasses. All of a sudden, it can tell the difference between a flat, dark patch on the radar that's actually a lake and another flat, dark patch that's just the shadow of a mountain. It understands the terrain, which cleans up the noise in a huge way. Fapnet's second superpower, the Neural Adaptive Patch Algorithm, is just as crucial. This isn't about what the AI sees, it's about how it learns. And it's a fundamentally smarter way to train an AI model. Think about it like this. The old way of training an AI was like giving it a giant textbook and telling it to study by just flipping to random pages. Yeah, it might learn some stuff, but it's going to miss a lot of the really important, tricky details. The app algorithm, Fapnet's way, is like a super smart study guide. It actively scans the map to find the hardest examples, the little streams, the fuzzy edges of a flood, what they call micro-water bodies, and it makes the AI practice those tough spots over and over again until it gets them right. So you've got this new AI armed with a better way to see and a smarter way to learn. What do you do next? Well, you put it to the test, of course. The researchers set up a full-on AI showdown. And this was no simple comparison. Fapnet went head-to-head with 8 other top-tier AI models, including the one that's been the industry standard for a while, called UNet. They tested them all on the exact same, very challenging data set from the Microsoft AI for Earth competition. So it was a truly fair fight. And the results were just nuts. They measured success using a key score called mean IOU. You can just think of it as a grade for how well the AI's map matches the real-world flood. Fapnet scored a stunning 87%. The previous best, UNet, was down at 79.5%. Even the original winner of that Microsoft competition only hit about 81%. Fapnet didn't just inch past the competition, it blew the doors off and set a completely new standard. But here's the real kicker. Look at this. Fapnet got that massive jump in accuracy without becoming some slow, bloated piece of software. It's just as lightweight, and its training time is nearly identical to UNet. It proves you can be way, way more accurate without sacrificing speed or efficiency. It's a true game changer. So, a higher score on a chart is awesome. For data scientists, sure. But what does this breakthrough actually mean for real people on the ground? The ones in the path of a flood? Well, it means everything. It means getting more accurate flood maps into the hands of first responders faster than ever so they can get help to the right places. It means we can track not just the huge, obvious flooded areas, but also the tiny streams that show how a flood is starting and spreading. And because it's so efficient, this isn't some pie-in-the-sky lab experiment. It's a tool that can be put to work right now. And listen, you don't have to take my word for it. The researchers who built it say it right here. They specifically designed it to be lightweight, robust, and simple enough to be deployed in the real world. This was built to solve a problem, period. And that leaves us with this final, really powerful thought. Today, an AI like Fapnet can map a disaster with a precision we've never had before. But what about tomorrow? As this tech gets even better at seeing the tiniest changes in water on the ground, could it go from just mapping disasters to actually helping us predict them, giving us the warning we need to get people out of harm's way before the flood even starts? Now that's the power of having a new eye in the sky.